Well, good morning, everybody. Greetings from the basement. We will continue on. We need to finish a little chunk, and then for the rest of the class, you will be doing homework review. But let me point out to certain things just to bring them back to memory. So what we have done so far in this material, we looked at skewed distributions. And what we learned that skewed distributions have those, data values that may be on the right or on the left, and they may affect the mean and standard deviation. So, and prior to that, we discussed that mean and standard deviation are very good numerical measures that represent center and spread. And now we have a new challenge. The challenge is we have not symmetric distribution, so it does not balance on seesaw perfectly. The mean is affected, and now we need to come up with something new, and we came up with the median. Again, it's just in the middle, so if you look at the very right, you could find, if you order your data, which is, again, requires technology, and if it requires technology, you might as well use the formulas. But anyway, you can find it by hand, and that would be the mean. The median is right in between, in the center. So you can also visualize a median on the histogram. And obviously, if it's a skewed right histogram, this is our tail here, and tail does affect it affects the balancing point, but area does not change as much. And so here is your kind of explanation why mean is affected, but not the median by those extreme data values and skewedness. So that's what we did so far. And we stopped here for quiz 1. And now we're ready to move on. And so continue for exam 1. So we need to finish that because that's something that we will have on the exam, and then we switch to a totally different, after the exam, we take a totally different look at data. We will start with bivariate data and do other exciting things. So anyway, so of course, when you have median, that's a measure of center. But how would you figure out a single number that would represent variability? And that shouldn't be standard deviation, because standard deviation is connected to the mean, and it's also affected. So an easy answer, how about look at quartiles, because median is in the middle, and we split each middle into the middle, and we get quartiles. And so we'll get 25% and 25% and 25% of the data. And then in the center, we will get 50% in the center. And that's IQR. Now, of course, easy done when you have those very simple data like we see here with the building blocks. But what if it's something more realistic data, like the one we are doing and it's posted on Talon? Not a big deal, because there are formulas. They are not on tests, because summaries will be given. So this would be on tests. And so, but now let's see how those, quartiles, how they land on the histogram, because we always want some kind of visual representation of the numbers. And it's very easy to figure out, because if you look at, like, say, median is the middle 50% and 50% of data in square inches. Just measure square inches, area in square inches. And so now if you divide this, it kind of goes like this. And if I divide again, I'm not pretending to be super accurate, but go like this. And now I can write, and again, on tests, answer choices will be so drastically different. You will not have any issues whatsoever to figure out what's correct answer. So don't be worried. Anybody may have slightly different picture, and this is 25%, and this is 25%. And so this is around 3, that's Q1. Again, remember those numbers are also slightly shifted. It's kind of the way Excel prints them. This is around 6, and that's Q2. Q2 is median, second quartile. And this is around 9, the way it landed. And so that's Q3. Yeah, now that's a good guess. Look at this. So that's a good guess. So now we're up for the new system that we can use for skewed distributions. Now, when distributions are skewed, you start paying attention where those extreme values go and where they land. So you start picking on the largest number and the smallest number. And so now we get that all in here, minimum, maximum, and that's called 5-number summary. Okay. So now, of course, what we learned is that you need to use median and IQR for skewed distributions. So for this, it will be, you would use median and IQR, and mean and standard deviation for symmetric. And this is for skewed. Okay, but remember, when we were introducing mean and standard deviation, mean is the measure of center. It's typical. Standard deviation is a measure of variability. And in the end, it helped us to figure out untypical. Because if you 2 standard deviations above or below, that's not typical, that's unusual. And so how would we do here? Because we thought we have median and IQR. There is a slightly different rule, and partly because IQR gives you the whole width. So IQR is not to the middle, but it's the whole width. And now we have 1.5 IQR rule. Of course, statisticians all over the world were thinking what would be the best, and that's they adapted 1.5 IQR rule, and it's built into technology. So if you look out for outliers in Excel, that's the rule is going to be used. And so now, instead of saying unusual, now we're going to say outliers. So actually, there is reason for that, and we will. Why would one be unusual? The other would be outliers. We will get to it. There is a good explanation. But now let's go here, and now that's what we have. And now we figure out. Now, of course, if you ask a layperson, like, where is an outlier? They'll say, that's outlier. But you can't do that. You need to actually formally check if it is. Outlier means doesn't belong to the rest of the data. And yes, it does not, but you have no right to say that unless you checked it, and that's what we need. We need to build the fences. And we have the formulas for the fences. And the formulas are, you just lower fence is Q1 minus 1.5 IQR, and IQR, as you see it here. And I'm writing it so that you know it doesn't come from out of the sky, and it's all visible, is 8 minus 3.25. But we're not, as you suspect, we're not going to crunch those numbers on the calculator. This is a little bit more advanced course than you would type some numbers in the calculator and then, you know, forget order of operations. And as a matter of fact, historically, this is where people forget the order of operations, because a lot of people who take statistics, they are not natural born mathematicians, and statistics is not mathematics. And so we'll figure out otherwise. And upper fence is Q3 plus 1.5 times IQR. Now, you're more than welcome to double check everything, but we have our stats calculator. Again, remember to download and enable editing. This is where we put our numbers. And so, well, I have it on a different screen, but I already entered them on the left here, so I don't need to type them in. And so, of course, we have negative 3.875, or we have 15.125. Those are our fences, and now we're gonna lay them down on our graph. Negative goes somewhere here. Nothing is outside the fence. Remember, outside the fence is outlier. Nothing is outside. But here, 15 point something, and yes, actually 16 is around here, because 0 goes here, 2 goes here. This is the way number line presented in Excel. So that's actually 16, and so 15 is around here. And so we have also might have an outlier hiding there. Depends on what it is exactly. So that would be 15.125. And so let's see what we have here, because this is our actual data. That's complete data set. And we have 19, which is over here. And I'm not finding anything more than 15. In this clause goes 14, but it's not outside the fence. It's to the left of it. Remember, this is individuals on the curve. We put the blocks to make the histogram, and it just not above 15, so it's not an outlier. Okay, wonderful. So now we know that 19, and I think what is our data? Oh, I forgot what we're measuring. Hours per week, yes. And so 19 hours per week is an outlier. And well, that means that typically 45 to 60-year-old men do not exercise that much. It's very unusual. That probably some kind of like ex-athlete or very involved in sports individual who ended up to be on that list. But like regular people don't spend that much time exercising. Okay, and so now of course, our next question is, now we got the 5-number summary, we got outliers and this and that. So how about making a picture for all of this? And the picture does exist. So unusual thing about that picture, that it represents the summary, not the actual data. Well, that's called box plot. And so now, of course, more data. Just an example, more data, little clicking on Talon. So that's not everything, more data on Talon. And so what you do then, so this is our data. You can download, again, those skills are not required on tests, but this is our data, and this is our man, and I already have the box plots, but let me select, okay, let me delete it just so. And so let me select man under 30 and man 45 to 60. Okay, clear the view here, sorry. And so selecting this stuff, and I want to insert box plots. Again, that's not you required to do on test, but you need to be aware that's an easy thing. And here we are. So why do we need those box plots? Because we can actually compare various data sets. So let's compare men under 30 to men 45 to 60. And for one thing, we see on those box plots, by the way, you see how the distribution is skewed. So it kind of stretches this way. So it is skewed. You see right away. Notice outliers. Remember how we summarize everything. Those are all, both data sets have outliers. Now you find the median here. And you find the IQR. So you see all of those important features represented in a graph. And so, of course, what would be the easiest, most transparent statement you can do looking at these two graphs? Obviously, you see that men 45 to 60 exercise more. Because the box of 50% is above. You see, the box is slightly above. And median for 45, 60 is above the median under 30. Well, someone who is 45 to 60, I can associate with that, and I can say when we are younger, when I was younger, I was more active and I didn't feel I need to exercise. My life was an exercise, but now I do. So that might be an explanation. Anyway, thanks for watching, and now you can finish the practice we started last class, and it's posted on Tell and Solve, so you can kind of check it out and see if you're on the right track. Well, I'll see you soon enough.